Hello, my name is Alexander Fitzsimons and this is a feature testing video for my Computer Science A-Level coursework. In this video I'll be testing the objectives that weren't mentioned in the previous videos. To do this, we'll be going over all the different panels that were included. This includes the toolbar, time settings, graph drawer, simulation display, information and teaching panel. Alongside this, we'll be testing features such as the simulation features, graph testing and extension objectives. In the simulation, the toolbar is to the left. This contains features to show the IDs of the objects, showing the velocity of the objects, showing the net force acting on each object, showing the trail of the object, so the path that it's traced, and changing the color of the next object you add in. To test these tools, we'll add in a few objects and test the features on them. Okay, so if we do show ID, a 1 appears above this object and a 0 appears above this object. And the higher the number, the later we've added them in. Show the velocity. The line indicates the direction and the size of the line indicates the speed that it's going. Show net force shows the force and the direction of the force indicated by this blue line. And show trail will draw a path behind the object where it has previously been. We can test the color wheel by clicking on a color, and you can change the brightness with this and add in an object of a different color. As you can see, the object that is larger keeps its own color when collisions occur. The next panel is the time panel. This includes pause and play, reset, which takes away any of the objects, speeding up time and slowing down time. To test the speeding up and slowing down time feature, we'll add in an object by itself so that we know it's at a constant speed, going to the right. And if we speed up time, we'll be able to see it travelling faster, and if we slow down time, we'll be able to see it travelling slower. If we pause it, we can see it stops altogether. We press play, it carries on going, and pressing reset will reset this. The next panel is the graph panel. This will draw graphs of different variables of objects in the simulation. If we just add some objects in to demonstrate this, we can start graphing by picking particular objects. If we show the IDs, we can see which one they are. So there's 0 and there's 1. So we'll pick the velocity in the x direction of object 0 and time in this direction, and then we start graphing. And it draws a graph of that. Other variables that we can measure include the net force, and this is times 10 to the 24 newtons per unit shown because it's so large. And we can start graphing. And when we press stop graphing, it should save that graph into the program folder. So here we are in the program folder, and in here is selected the saved graph.jpg. And as you can see, this is the exact same graph that was drawn in the program. Of course, the x-axis doesn't always have to be time. If we change this to net force, we can change this to something else like velocity in the x direction. And if we start graphing, it'll start drawing something probably not a sine wave, as it's not a function of time. There we go, it makes some sort of oval ellipse shape. The next panel is the simulation display. This is what contains all of the different objects that the user can add in, and it will allow them to visualize what's actually happening. The information panel gives information about the current simulation. For example, this is the current radius, 5 million meters, or 5,000 kilometers. So, when you change the size of the pointer in the simulation, this changes the size of the current radius, allowing the user to see in metric units what the size of the object they're adding in is. Let's reset that. The next one down is current density. This tells you the density, or the mass per volume, of the current object. Right now it's set at 5,500 kilograms per meters cubed, which is about the density of the planet Earth. And you can change the density of the planet to be added in next by doing Shift D and scrolling up or down depending on whether you want to increase or decrease the density. Let's reset that again. The current scale tells you how many meters there are per pixel on the screen. So for example, if we were to press Shift and Z and scroll in and out, you'll be able to change the amount of meters per pixel on the screen. The next is the current speed of time, which tells you how fast time in the simulation is moving relative to normal time in the real world. So right now it's set at 10,000 times the normal speed of time, and the reason it's so fast is because we're talking about astronomical distances, which means things appear slower on a smaller screen. So if we press play, you'll be able to see that they still move quite slowly even at this 10,000 times the speed of normal time. If we speed this up, you'll be able to see that it moves faster. The next panel is the Learn panel. Within this, the user can learn about the physics and the mathematics that goes on behind the simulation. So if we click and hold on the motion, it shows the equations for constant acceleration. Now of course, in the actual simulation, it's not always constant acceleration, but at any one instant you can use some of these equations to calculate the velocities of objects in one particular instant of time. Gravity teaches you the Newton's laws of gravitation, where F equals gmm over r squared, where g is the gravitational constant, m is the mass of one of the object, lowercase m is the mass of the other object, and r is the distance between the two objects, and F is the force acting on the objects. Kepler's second law is actually a demonstration. We have to set up a simulation properly to do this. When you try and click Kepler's second law when there are not enough objects, it will say there must be exactly 2 objects in the simulation for this. And the same applies when there's more than 2 objects. So if we set up an orbit like this, it's a highly elliptical orbit. If we turn the trail on, you'll be able to see that. We can speed this up slightly. There we go. And if we click on Kepler's second law, it says a radius vector joining any 2 objects sweeps out equal areas in equal lengths of time, also known as the green area equals the blue area. So that is another concept in physics that is taught, which is why I've included this in the program. The final test isn't to do with any panel, but it's the instructions. If you click and hold here, it gives you instructions about these panels on the side. More instructions teaches you more about the what to do with the simulation in general. This has been feature testing my program. Thanks for watching.